now, and please tell everyone to join as soon as possible. Okay, so I'm left with a very little bit portion. So last day we have discussed different access specifiers and different mode of inheritance. We have already completed public mode of inheritance and protected access specifiers. Now let's discuss about different visibility modes and different mode of inheritances, and how the data members works in various mode of inheritance. So for that, say let us take one example. So there is a class B and we have inherited class B. We have inherited class B to create a new class D. So D is a derived class and it is derived in public mode. So D is derived in public mode, and there is a class E which is derived as private, and another class F that is derived as protected. So we know that different mode of access or different access specifiers and their corresponding properties. So we know that if something is derived as public, everything will be remaining public. Okay, so just go back and consider this table. This table. So if the base class members is prime, this is the access specifier of base class member. If the base class member is private, then private members are inherited but not accessed, and if even if whatever be the derivation technique, whether it is public or whether it is private. Okay, and the public data members, if there is a public data member, it remains public in case of public derivation, and it becomes private in case of private derivation. Now we have added one more member, that is protected. One more type of member access specifier is there, that is protected. So we know that if there is protected members, they are inherited just by the next derived class, immediately derived class. They can be accessed from within, only accessed within from the immediate derived class. So there are certain rules related to this and we need to update this table. So for that, let us see what will be different access specifiers and how how they differ across different mode of inheritance. So let us consider this example, and if say for example B is a class and we have taken X, Y and Z as the members of B. One is public member, another is protected, and Z is private member. Now we know that the easy relationship is between the public is between D and E and F. Okay, but this mode of inheritance for D, whenever we create D, the mode of inheritance is public. Okay, so for public mode of inheritance, we can say this is a easy relationship, and that is this easy relationship is having a standard notation, that this arrow. Okay, but for the inheritance mode protected and for the inheritance mode private, there is no standard notation. So this dashed line and this dotted line, they are not standard notation. Okay, so these notations I have used to make the difference between the public mode of inheritance, protected mode of inheritance and private mode of inheritance. So what here I have done, I will check in all this mode of inheritance. I will check how which means data members are accessed, okay, and which data member are not accessed. Okay, so the strike, if I have strike through the data members that are inherited but not accessed. Okay, so strike of denotes inherited but inaccessible. So here you can see in public mode of inheritance, this D, when I created D, the public data member X is okay. It can be accessible. Protected is also accessible because it is the immediately derived class. And private members are inherited but not accessible. Similarly, in protected mode of inheritance, you see the member that was public in B, it becomes protected here because it is protected mode of inheritance. Okay. And Y remains protected because it was previously as protected, and private Z is inaccessible. Similarly, for private mode of inheritance, all the members, whatever be public, protected, etc., all become private. So these two are accessible from within F. Even if they are private, they were previously public and protected. Okay. So they are accessible, but this one is not at all accessible. Okay, so I'm coming to this point just after this discussion, that what are the private mode of inheritance and what is its use. Okay, so let us consider a table, new table. I have updated this table that I have discussed, that this is the mode of inheritance. This is the members access specifier, base members. This is base members. And if the base member is public and the derivation is public, it remains public. It becomes protected if the derivation technique is protected, and it becomes private if it is private. So you can see this. For public derivation, X remains public. For protected, X becomes protected, and for private, X becomes private. So any member that is public in the base class, it takes the form, okay, form of inheritance mode. In which mode it is inherited, it takes the form. It changes the form in that way. And for the protected data members, if the data member is protected and the derivation is public, it remains protected. For protected, it also remains protected, and for private, it becomes private. Okay. So private mode of inheritance, a protected member acts in this way. That means if any member that is protected in the base class, it remains protected until and unless somebody makes it private. That means for private inheritance only it is changing. Okay, so protected is a little bit better than public. Public, like, it can be accessible for everyone and it can be converted to any form. But protected changes its form only to private if the derivation technique is private. Okay, and for private everything remains private. Okay, so let us see this one. This is a visibility matrix, and considering this visibility matrix, let us take one more level of inheritance. Okay, and see what happens. Okay, so I have so this is just the pictorial view of this table. Okay, the same rules are written here. Just we need to remember that public, if the member is public, it can take any form depending on the inheritance mode. And for protected, only it will change if the inheritance mode is private. And for private, everything remains private. Okay, so this is the same thing I have discussed here. Just see the picture. So this is class D. It is inherited as private. Class D1 is inherited as public. Okay, and this one class. So here multiple inheritance occurs where public D1 is inherited as public and D2 is inherited as protected. So the members going, the arrow showing that which member becomes what. Okay, so let us consider one more example to see this thing in a bit detail. Okay, so this is an example that shows the accessibility under various inheritance modes. Okay, so you see here what I have done. I have taken one class A with 3 data member X, Y, and Z. Class B, for every class I have taken different data members. Okay, so the yellow portion, you see the picture, the yellow portion shows that whatever the data member for A. Okay, and then this yellow portion comes as inherited, and the gray portion, that is the data member, its own data member, that means B's own data member. Similarly, this portion is coming, and this is the this U, V, and W is C's own data member. Okay, so this is this this is public mode of inheritance. Here inherited as public, and this is protected, and this is private. Okay. So what happens here? We have considered one more level of inheritance. So all this level for E, F, and G, for simplicity, we keep them as public mode of inheritance. So you can see here, whenever we create B, B is created as public from public A, C is created as protected A, and D is created as private. And for the next level of inheritance, that is for E, F, and G, this is public, public, and public. Okay. So now this one we have checked with a normal global function. Okay. So I have checked with a global function efficiency, and I have tried which all are means which all elements or members will be accessed, that I have written here. So you see, for this one, for A, okay, from outside the class definition, that means for A, the base class, which member is accessible. Okay, so outside class from a global function, which all members, that is what is the view. Okay, we'll be considering the view from a global function. Okay, are you getting my point?
Yes, ma'am.
So from a global function, we will check. So from a global function, we will check that which all will be accessed. Okay, just a second. Okay, so this one, for A, this public Z, this means this member, if I write down, if I create this A is an reference of this class. Okay, so I have created small a, small b, all are objects of this class, and then we can access this one. This one is correct. Okay, only the correct, whatever is accessible, that I have written. So what happens, you see, whenever we do the public derivation, okay, then this remains private remains private. Sorry, the private remains private. Then the protected remains protected, and public remains public. So Z is coming as public. Okay, and for B, these are the new members U, V, and W, public, private, and protected. Okay, for protected access specifier, this private member, it is means inherited as private but not accessible. That's why it is crossed. Okay, and the protected Y remains protected, and public Z becomes protected. Okay, and these are their member. Okay, similarly for D, everything becomes private. You see, these two becomes private and it remains private. Okay, now next, what happens whenever we do this? All these are public mode of inheritance. So these are public mode of inheritance. Now see what comes in E. Okay, so here in E, you see it is public. Okay, so these are the data members: private, protected, public. So these data members and these data members, the yellow and as well as the gray part, all are coming into E. Okay, so the private part is inherited but not accessed. That's why crossed. Protected remains protected, public remains public, protected remains protected, public remains public. Okay, but for here, this is public mode of inheritance. Okay, so these, whatever they become, protected and protected, Y and Z, they remains protected, and This one private U, it is not accessible. Protected remains protected and public remains public. Okay. For public mode of inheritance, whatever be, it will be coming like that only. Okay. And for this one is also public. So here what happens here, this one is private. So this AX is not accessible, inherited but not accessible. And these two were previously Y and Z were become private by this mode of inheritance. So they are also inherited but not accessible. Previously they were inherited from there, but they were accessible because they were protected and public before inheritance. Okay. And here the same rule for public, this one is not accessible, these two are accessible. Okay, so that's why it is written for A only this Z is accessible, A for Z, and for B which two are accessible, Z and W, because these are public members. We cannot access protected members Y and V and U. All are private or protected. We cannot access them. We cannot view them from any global function that is outside of the class. That's why Y and V are not accessible. Only Z and W. Only Z, that is this is also public, and Z and W, this is also public. For B, these two are accessible. For C, which two are accessible? Which one is accessible? Because these are protected, Y and Z are protected. So for C, only W is accessible. Okay. For D also, only W is accessible because Y, Z and V and U. Y and Z are private, U also private, and V is protected. Okay, so it is not accessible from outside the class. And here you check for E, both are public, Z and W. So for E, Z and W is accessible. For F, even if the just above the level of inheritance, W is accessible, these two are protected, they remains protected. So only W is accessible for F. And for G also, only W is accessible. Okay. So are you getting my point? What I want to tell? So are you getting this one? This rule?
Yes, ma'am.
Yes. So always remember this rule. Okay, whenever we consider any mode of access specifier, whatever be the inheritance mode, you just consider these rules and accordingly you program the code. Okay. So this is how all the modes and how it differs and how it accessible, remains accessible or not accessible. It depends on the visibility modes. Okay. So next is let us take a private mode of inheritance a little bit more. Okay. So if this is the example, okay, there is one class and class B, and I have created I have created class E as private, but it is written here D. I forgot to change it. E as private inheritance from B. Okay. So let's see what happened. Okay. So or what is the use of this? So for this I have considered two examples. Okay. So first consider the left one. So in the left one I have created class B. This is the base class. So what I have done here, I have taken one, this is private data member and two public data members, B1 and B2. And this is the initializer list by which we are passing value to this B1 and B2. Okay, we are just initializing them. So this is the constructor, B is the constructor. Having two variables X and Y. Okay, and then we are passing this value X and Y to initialize B1 and B2. Okay, so this one is simple. Already we have discussed these things. Now what I have done, I have created one class D, privately inherited from B. Okay. So what happened? as per our rule that the whatever B is private, it will not be accessed. Whatever B part is private, it is inaccessible. And B1 and B2, they were public previously, so they become private here, but they are accessible. So even if they become private, they are accessible. Okay, within a local function that is local to D. Okay, so D, Fn is a member function of D, so that's why it can access its private data members. So whenever we create D, if there is no other data member other than the inherited one, so it has inherited B, it has inherited B1, and it has inherited B2. So B1 and B2 was previously public, but now they become private, and this was the private. So this is inaccessible, that we know. These two, B1 and B2, they are accessible by the member function that is local to this class. That is as per the rule of object-oriented programming. Okay. So if I write down, if I try to access the base class private member, this is inaccessible. This we can do. Okay. If I want to access B, we cannot access B. But if we want to access B1 and B2, we can access, because these are private. Even if they are private, they are the member of this class. And we know that public functions can access the private members of the same class. Okay, so this one is fine. Now what I have tried to do, I have tried to call the same member function from outside this class definition, from main. Okay, from a global point. Okay, so in main, I have created one object D, small d, and with D I am calling Fn. Okay. So for this, it will work because d.fn, this is work as per object-oriented technology rules. But in Fn, we cannot access B. We can access B1 and B2. Okay. If I want to access these two, they are inaccessible. They will be giving you some error. Okay. So when you inherit privately, all the public members of the base class, they become private. If you want any of them to be visible, okay, from within this main, that time you need to do a very little change in it. There is a keyword called using. So now you go to the next example, the right side. Okay, the same thing I have done, but what I try that if they are accessible from this class, okay, previously they were public, so can we access, and we are making them private. Okay, so what we are, my objective that B1 and B2, they were public, and I am after inheritance they become private. So can we have a little bit or portion of this B1, B2 hide, and a portion can be shown. Okay, so we can publicize the privately inherited members. That means we can make a little bit of public. That means we can make it available, a part of the private data members that are inherited. Means after inheritance they become private. Okay, so what can be done? This using keyword, this can be done. Okay, so private inheritance is useful if you want to hide part of the data of the base class. So from here, from this base class, B1 and B2 are inherited as private. So our aim is to make anything private because we want to protect the data. We want to hide the data from outside access, but sometimes it may require that the private data members is given a little bit of access. Or if you want to publicize the privately inherited data members, we can use this using keyword. So by using keyword, we'll be writing this using, then the class name, scope resolution, that means B2 belongs to which class. So B2 belongs to this class. If we want this one, now here this line will work. Previously this line is not working, but in main this line will work. Okay. So we are actually explicitly we are publicizing this B2. Okay. So in B we are explicitly mentioning that even if it is inherited and become private, here you can access it. Okay, so sometimes it is required that a part of data to be hidden and part to be shown. That time we will be using this private mode of inheritance. Okay, so you understand this thing, the usefulness of private mode of inheritance, right? Okay.
Yes, ma'am. Yes, ma'am.
Okay, so next is I'll be discussing one more example that shows the difference between public mode of inheritance and private mode of inheritance. Okay, so for simplicity, I have not taken the body of these two classes. What I have tried to create here I have tried to create one class teacher and another class teach assistant from teacher. Okay, teach assistant is actually inherited publicly from teacher. So the idea is that teacher is a class which can teach. Okay, and teach assistant is another class which is inheriting all the properties of teacher. That means they can also teach and say for example a research scholar, okay, who is doing research under some teacher. Okay, so that teacher can teach, the research scholar can also take some tutorial and can teach. Okay, and along with that they can attend some lectures. So that's why I have created two global function teach. In teach I have passed the reference of teacher T. Okay, and it calls of means it just displays that teach is called, and attend lecture. In attend lecture I have passed the reference of teacher assistant. That means teach assistant. Okay, so teach assistant, what it will do, it's like you can visualize one teacher and their scholar. Okay, the scholar can means teach as well as he or she can attend some lectures, but the reverse is not true. That means say the son is having inheriting some properties, characteristics from father. Okay, but father will not inherit any characteristic of son. The reverse is not true. Okay, so that's the scenario I'm trying to create here. With this there are two global functions. Now what I'm doing, I tried to create two objects x and y, one for teacher and y is for teach assistant, and then I called the function teach with this x. Okay, so what is the type of x? X is, what is the data type of x? It is an object of teacher class. Okay, so will it work, this one? Because x, in x we are passing this one, so this matching, will it work? X is also teacher type and T is also teacher type, so we are taking the reference. It must work because the type is matched, isn't it?
Yes, ma'am. Yes, ma'am.
Now the next thing what I am trying, that I am passing teach assistant y. Okay, the teach assistant y, this object I am passing here. So will it work, this one? This is of teach assistant type. The type is teach assistant, but we are passing teacher. So will it work? It should not work, isn't it? Are you getting my point? Why it should not work? Right? Yes? Are you there?
Yes, ma'am. Yes, ma'am.
So it must not work because y is of teach assistant type, but we are passing reference for a teacher. So type mismatch occurs. Okay, but surprisingly it works because if the inheritance is public, inheritance mode is public. Okay, the derived class object gets converted by the compiler to a base class object in public mode of inheritance. Means this derived class object, this is the derived class object, it gets converted to a type of the base class object. So that's why it works. But the reverse is not true. If we pass X in attend lecture, it will not work. But this one is work because type match occurs. Okay, so this is why if you have public mode of inheritance, this conversion is done. It should not work, but due to the conversion, due to the automatic conversion by the compiler, it happens. But this will not work if the mode of inheritance is private. If the mode of inheritance is private, it will not work. If you provide this thing, it will not work. Okay. So this is also an usefulness of private mode of inheritance. So in case of private mode of inheritance, the derived class object, it does not get converted by the compiler to a base object. Okay, so this is how we can restrict different things. Okay, so you understand this example?
Yes, ma'am. Yes, ma'am.
Okay, okay. So this one is, let us see one more example, but this is the example of inheritance and composition. Okay. So do you know what is composition? Or you remember this one, is a relationship and has a relationship?
Yes, ma'am. Yes, ma'am.
Okay, so let us take this example. Okay, and try to understand this thing. Okay, how it composed of. Okay, so here I have created one class B, and you see how the class B is created. It is having one constructor which passes one variable parameter, and this constructor is constructing XA. Very simple definition. Okay, and I am trying to see that during the call how the constructors and destructors are called. Okay, so next is class C is created with public mode of inheritance, and class C, that it is having some private data member, and class C, this is the derived class constructor. So we know that if there is a constructor derived class, if there is a class derived from any other class, the derived class constructor is having the responsibility to construct the base class constructors, isn't it? It will be passing the value to the base class. So that's why this is the definition of the derived class constructor. So the initializer list is, from the initializer list you can see this is how C is, this class C constructor is constructing class B. So whenever this C is called, it will first construct this one, it will first call this one B, and then it will pass the value to, it will construct itself class C. So this part you understand, na?
Yes, ma'am. Yes, ma'am.
Now see what happens if I create one more class D. Okay, so this class D is created by private mode of inheritance from C, and D is composed of an object of C. So here I have reused C in D, but what we are doing, we are creating an object of C here in D. So we can say that D is composed of C. So if I consider this one, that we are creating an object of D, if we are creating an object of D, so this is how it must look like. Okay, so D what it has, D is composed of Z, and it has inherited some members from C. Is it okay? You understand this thing? Why this is Z, it composed of some part Z. Z is, first you consider this one, first you consider this C. Okay, whenever we create C, C is having all the members of B. C is having all the members of B along with its own data member. C is having These two. So this is C. This outer thing is C. Okay. Now when I create any object of this class D, see the definition of D. So D has inherited some part of C, and it has also an object of C. So there are two parts. One part is inherited from C and another part is composed of Z. So in D, one part is inherited from C, another part is from Z. And Z is what? Z is nothing but an object of capital C. So that's why in Z also B is there and some portion of C is there. Because Z is a type of C, object of C. Are you getting my point? So here what happens in the constructor of D, it is now our responsibility whenever we do construction. What is the responsibility? The responsibility of the constructor D is to pass parameters to the constructor from where it is created. So whenever we do this one, CD, so whenever we want to construct D, it will call C. And then whenever we want to construct C, C will call B. Okay. Now can you say this pair of BC and this pair of BC and this D belongs to which class or which calls? Can you tell me? Certainly this D is for this one whenever it is created. So we know that whenever any object is created, its constructors are automatically called. This thing is known. So this last D is for this. Okay. But this BC and this BC, this is for what? For which calls? Can you guess? So whenever we create D, it calls here, it comes here, and it tries to create CD. Isn't it? It tried to create CD. So this CD belongs to which? This, whenever this CD is called, this one, the control goes here. So then B is called and here B is outputted. So this part, this CD and this Z. So this portion actually belongs to which call? Inherited portion or composed portion? Tell me.
Inherited.
This part belongs to this inherited portion. And next, this Z, we are constructing this Z. So when we construct this Z, this is also, Z is also type of C. So again, C need to be constructed, and when C is constructing, B need to be constructed. So this BC belongs to this composed part. So it's little bit tricky. You understand this thing now? And we know that whenever we come out of this block, anything that is constructed need to be destroyed, and the destruction order is just the reverse of the construction order. This thing is simple. So you understand this thing, this example?
Yes, ma'am. Yes, ma'am.
Okay, so this up to this is what we need to discuss. Okay, and then this is, we can say, the private mode of inheritance. When we inherit something, we can say that we are doing or we are implementing in terms of relationship or implemented as in relationship, not the is a relationship. Because private inheritance, it is not providing you generalization and specialization one. It's a little bit different than the public. Okay, so we can say that this is not considering the is a relationship, rather it models a implemented as relationship. Okay, so just to summarize everything. Okay, I'm not protected mode of inheritance also I'm not discussing different things, because we know that whenever you do the protected mode of inheritance, what happens. Just you remember the rules and then it will act accordingly. Okay, so next is just to summarize the whole thing, that in public mode of inheritance it implements is a relationship, and private mode of inheritance, it does not implement the is a relationship, it implements in terms of or implemented as relationship. Okay, and protected also, it does not mean generalization and specialization. Okay, that means the reverse is not true here also. And we can override, overload, or add member functions while we deriving in public mode of inheritance. And the constructor, destructors, and then equal to operator, friend function, they cannot be inherited. Okay, and the visibility matrix also we have discussed, that particular table that you need to refer time to time whenever we will be creating different types of inheritance. Okay, so up to this, you have any query? So you understand the rules, na? That rules are very important. These rules. Rules.
Yes.
Okay, so you remember this thing. So do you have any other query, or you are not any question or anything that you have not understood? Okay, you understand this thing, na?
Yes, ma'am. Yes, ma'am.
Okay. Okay, so today I'm leaving you, and
Hello.
ha.